Welcome students. Today we'll discuss lesson 42 of class 12 physics. In this lesson we will discuss fringe width, which is from the chapter 11 wave optics. Now in our previous lessons we have seen Young's double slit experiment, and we have seen it produces your bright and dark fringes. Then we have obtained the path difference. After that, we have obtained the position of the bright fringe and the position of the dark fringe. After that, we have obtained the conditions for the bright fringe and the condition for the dark fringe. Now, in today's class, we will find the fringe width. Fringe width. It is the separation between two successive bright or dark fringes. So, this is how your bright and dark fringes look. So, fringe width is the separation between two successive bright fringe. This is your fringe width, or it is the difference between the two successive dark fringe. This is your fringe width. Fine. Now, in order to find out the width of this dark fringe, what we will do is, as we know, the position of this bright fringe, which is XN, and the previous bright fringe, which will be XN minus 1, then in order to find out the length of this dark fringe, or in order to find out the fringe width, or in order to find the separation between the two consecutive bright fringe, what I will do, I will subtract the n minus 1th order bright fringe position from nth bright fringe, or I can say, let us say this is your x2, this is your second bright fringe, this is your first bright fringe. So in order to find the width of this first dark fringe, what I will do is I will subtract x1 from x2. What does this x1 gives? It gives me the position of this first order bright fringe. What is x2? x2 gives me the position of the second bright fringe. Fine. So width of a dark fringe equals to separation between two consecutive bright fringe, xn minus xn minus 1. Now we know xn equals to n d lambda by d. N is the nth order, d is the distance between the screen and the slit, lambda is the wavelength of the light used, and d is the distance between the two slits. So n minus 1 order bright fringe will be n minus 1 d lambda by d. Fine. So if you simplify this one, we will get d lambda by d. So what is the width of the dark fringe? It is d lambda by small d. Fine. Now let's find the width of the bright fringe. So the width of the bright fringe equals to separation between two consecutive dark fringes. So let us say we will try to find out the width of this bright fringe. let us say this is your first dark fringe, this is your second dark fringe, and this is your first bright fringe. In order to find out the width of this bright fringe, what you will do, you will position, or you can subtract the position of the first dark fringe from your second dark fringe. Fine. So basically it is the separation between x nth dark fringe and x n minus 1th dark fringe. Fine. The width of the bright fringe is the separation between the two consecutive dark fringe, xn dash minus 1 dash. As we have derived the position of the dark fringe, which is twice of n minus 1 d lambda by 2d. Fine. And what will be the n minus 1 dark fringe? It will be 2, 2, but this time n minus 1. So I'll write n minus 1 instead of n minus 1, and then again minus 1, d lambda by 2d. Again, d is the distance between the screen and the slit, lambda is the wavelength used, and small d is the distance between the two slits. Fine. Okay. Now, when you will, what will happen? This 2n and this 2n will get cancelled. This minus 1 and this minus 1 will get cancelled. The one will be remaining is minus 2, and this minus and minus will become plus. This 2 and this 2 will get cancelled. So I'll have d lambda by small d. So width of the bright fringe is d lambda by small d. Now clearly the width of the bright fringe as well as the dark fringe are the same, which is d lambda by small d. So hence the expression for the fringe width in Young's double slit experiment, which is denoted with beta. So beta equals to d lambda by small d. Fine. Now in order to find out the wavelength, you can send this term here. D will go to the denominator and small d will come to the numerator. So d by capital D. This will give me the wavelength. So measurement of the wavelength, lambda equals to beta times small d divided by your capital D. Okay. So on the basis of fringe width, we can solve some examples. Let's take your first example. In Young's double slit experiment, two parallel slits are made of apart. So this will be your small d, and the screen is placed 1 meter away. 1 meter away, this will be your capital D. What is the fringe separation? They have asked you to find out fringe separation, means your fringe width, which is beta. When the blue-green light of wavelength 500 nanometer is used, they have given you the wavelength. Fine. So the small distance is how much, or the small d is how much? 1 millimeter. Millimeter, when you convert it to meter, you multiply it with 10 to the power minus 3. So distance between the parallel slit equals to 10 to the power minus 3. Next, your distance between the source and the slit, it is 1 meter. Fine. Next, they have given you the wavelength, lambda equals to 500 nanometer. N means your nano. Nano is how much? 10 to the power minus 9. So I can write it as 500 times 10 to the power minus 9 meter. So fringe width beta equals to d lambda by small d. Fine. D they have given, it is 1 meter. So I'll write down 1 here. Lambda is 500 times 10 to the power minus 9, 500 times 10 to the power minus 9, and small d equals to 10 to the power minus 3 meter, 10 to the power minus 3 meter. Fine. Now 10 to the power minus 3, when it goes to the numerator, this will become 10 to the power minus 6. Now here are two zeros. I can cancel these two zeros and this will become 10 to the power minus 4. So I have 5 times 10 to the power minus 4 meter. Fine. We know that 10 to the power minus 3 is your 1 millimeter, and we have 10 to the power minus 4, so I'm still left with 10 to the power minus 1. So if I multiply this with 5, I will have 0.5, and this 10 to the power minus 3 will give me milli. So the answer will be 0.5 millimeter. So what is the fringe width? This distance, the fringe width will be how much? 0.5 millimeter. That means the fringe width for the bright fringe will also be 0.5 meter. The fringe width for the dark fringe will also be 0.5 meter. Fine. On the similar note, you can take the another question as your homework. So the question, this example states laser light of wavelength 600. This is the wavelength lambda. This is given in nanometer. That means 10 to the power minus 9 meter. Incident on a pair of slits produce a interference pattern. Okay, they are producing interference in which the bright fringe are separated by 8.1 millimeters. So they have given you the separation between the bright fringe, which means they have given you the fringe width. Beta is how much? 8.1 millimeter. Fine. Now a second light produces an interference pattern. Now this time, instead of using 630 nanometer, they have used light of another wavelength. In that case, it also produces your bright fringe. Bright fringe how much? 7.2 millimeter. In this case, let us say this produces a fringe with beta dash how much? 7.2 millimeter. Now they have asked you to find out the wavelength of the second light. Now to calculate the wavelength, you know the formula, lambda equals to beta small d by capital D. Let us say this is your first wavelength and they have asked you to calculate your second wavelength, lambda 2. Fine. So if I calculate wavelength, okay, this is your lambda 1. It produces a fringe with 8.1 millimeter. Fine. And they have asked you to calculate your second wavelength, lambda 2. This is your beta 2 d by capital D. Fine. Now in this case, what happens? Your small d, that means the distance between the two slits are same. Capital D means your distance between the screen and the slit is same. So what you can do is you can take the same part at one side and take the variable part on the other. Let us say I'll take the same part on the left hand side, so I can write d by small d equals to beta by lambda 1. Similarly here I can write d by d equals to beta, this is beta dash divided by your lambda 2. They have asked you to find out this lambda 2. Now since this one and this one are equal, you can equate these two values. So I have beta 1 by this is just beta, this is lambda 1, and this is beta dash divided by your lambda 2. They have asked you to find out this lambda 2. Send it here, send this beta to the denominator, wavelength to the numerator. So I can also write it as lambda 2 equals to beta dash divided by your beta into this lambda will go to the numerator. Fine. Now beta dash, they have given how much? It is 8.1 millimeter. Beta is how much? Sorry, dash is how much? It is 7.2 millimeter. 7.2. What is beta? Beta is 8.1. See, millimeter will get cancelled, so it will be 7.2 divided by 81. Fine. Now next you have lambda 1. What is the first wavelength? 630 nanometer. Let it be nanometer itself. Okay. So you can use your calculator to calculate this value, and you can submit this question as your homework. Fine. So that's it for today's class. Thank you. And if you have any confusion, please don't hesitate to ask. I will re-explain it to you again.